All right, we're going to continue the review for exam 2, or for the review for exam 2. Number 16 says we need to find f plus g of x. And so we get that by adding f and g together. So this means f of x plus g of x. And of course, f of x is the square root of x plus 3. G of x is x plus 2 over x minus 1. Well, we can't add those together, so that's all we need to do. For f minus h of x, this is f of x minus h of x. Now f of x is the square root of x plus 3, and h of x is x minus 5. Now be careful here. You do need the parentheses around this because otherwise you're going to miss distributing the negative. You're subtracting a binomial here, and so that will change your signs. You'll get minus x and a plus 5. And again, that's all we can do. For g times x, that's g of x times h of x. And so g of x is x plus 2 over x minus 1. H of x is x minus 5. We need to multiply the numerators and the denominator, so we'll put that over 1. So we're going to get x plus 2 times x minus 5 in the numerator over x minus 1, and we'll just leave it like that. On letter K, this is going to be f of x over h of x. And so it'll be the square root of x plus 3 over h of x, which is x minus 5. Now on number L, if this were f plus g of x, we'd say f of x plus g of x. The only difference is instead of being f of x plus g of x, it's going to be f of 6 plus g of 6. And so we can find f of 6 by plugging 6 into the f function. That'll be the square root of 6 plus 3, or the square root of 9, which is 3, plus g of 6, we'll plug 6 into the g function. We get 6 plus 2 over 6 minus 1, which is 8 over 5. And in order to add these, we need a common denominator. I need to multiply by 5 over 5. So 15 over 5 plus 8 over 5, and we get 23/5. Now there are two other ways you could write this, either 4 3/5 or 4.6. On letter M here, we got f of 7 minus h of 7. F of 7 is going to be the square root of 7 plus 3, and that's just square root of 10, minus h of 7. Well, that's going to be 7 minus 5, which is 2. Square root of 10 minus 2, we can't do anything to combine those. That's how we're going to leave our answer. And then the final one here, this will be h of negative 1 times g of negative 1. So h of negative 1, we're going to get negative 6. G of negative 1, we'll plug a negative 1 in here. And we're going to get negative 1 plus 2 over negative 1 minus 1. That's 1 over negative 2, or negative a half. And a negative times a negative positive, and 6 halves make a whole, or make 3. 6 times a half, you should get 3. All right, let's move on to number 17. So this is f of g of 3. F of g of 5. So we're going to write that as f of g of 5. That's what that means. And so notice, first of all, we want to plug 5 into the g function. That'll be 5 plus 3, which is 8. So g of 5 is just 8. So we're going to find f of 8. So now we're going to plug 8 into the f function. That's 8 squared, which is 64. So if you haven't already, you might try doing g of f of 5 and then checking your answer on the video. Alright, so it should be g of f of 5. We can find f of 5. That's just 5 squared. So that's going to be 25. So f of 5 we replace with what it's equal to, which is 25. And now we'll plug 25 into the g function. So it'll be 25 plus 3, which is 28. So letter C, we're going to find f of g of x and then state the domain. So this is read f of g of x, and that's how we read the second line here, which is what this means. So notice what's happening. We're plugging g of x into the f function where g of x is an input. Well, g of x is x plus 3. Now what does the f function do? F of x equals x squared, so you square whatever the input is. So we're going to square our input, which in this case is x plus 3. So this is what I call FOIL in disguise. We're going to have to multiply two of these, and when we do that, we're going to end up with x squared plus 6x plus 9. Now to determine the domain, first of all we look at the domain of the inner function, which is g of x. Well, that's a linear function, so it's got a domain of all real numbers. And then there's a couple of ways to do this, but the way I do it is I'll look at the final answer that we got here and see if there's any more restrictions. Well, that's quadratic, so there's no restrictions on x. So our domain is just going to be all real numbers for f of g. Let's find g of f of x next. Again, you may want to try this one first before you look at the video. So it's going to be g of f of x. That's how we say that. That's what it means. F of x is x squared. So x squared is the input for the g function now. The g function takes your input and adds 3. So it'll be x squared plus 3. Don't really need the parentheses there. So our input was f of x, which is x squared, and that has a domain of all real numbers. And if you look at our final answer, x squared plus 3, that also has a domain of all real numbers. It's quadratic. And so there are no restrictions on this one. It's just going to be all real numbers. All right, let's move on to number 18. So f of g of 4 will look like that. Let's find g of 4. So it'll be 2 times 4 squared minus 1. That's 2 times 16 minus 1. That'll be 32 minus 1, which is 31. So now we'll find f of 31. Since g of 4 was 31, we're just replacing g of 4 with 31. F of 31, it'll be 3 times 31 plus 2. And so that's going to be 93 plus 2, which is 95. So again, I'd encourage you to try B if you didn't already do it before, and then watch the video. So this is g of f of 2. But f of 2, we can find that. That's 3 times 2 plus 2. 6 plus 2, we're going to get 8. So this is g of 8. And now we'll plug 8 into the g function. And so that's going to be 64 times 2 minus 1. That's 128 minus 1, which is 127. All right, let's go ahead and find f of g of x. So g of x here is 2x squared minus 1. We're going to plug that into the f function. It'll be 3 times my input plus 2. My input here is 2x squared minus 1. So all I need to do is distribute here. You'll get 6x squared minus 3. Bring down the 2, and then we can combine the minus 3 and the 2. We get 6x squared minus 1. And then we have g of f of x. And f of x is 3x plus 2. And so we're going to plug that into the g function. So let me make a skeleton here. It's 2 times my input squared minus 1. This is the g function, so we're going to plug in 3x plus 2 as an input. So we have some work to do here. We're going to have to square 3x plus 2. When you FOIL that out, you're going to end up getting 9x squared plus 12x plus 4. So we have to distribute that by 2 times 2. And don't forget the minus 1. And so let me go ahead and distribute there and bring down the minus 1. And 8 minus 1 is 7. So our final answer is 18x squared plus 24x plus 7. All right, let's move on to 19. So we're going to do some more of this. F of g of x, that looks like that. So the g of x function is 2x minus 3. We're going to plug that into the f function. So 2x minus 3 is my input there. You don't really need the parentheses. We can combine the minus 3 and 1. And so we get the square root of 2x minus 2. It does say that we need to find the domain here. So first of all, we look at the inner function g of x. And that's a linear function, so the domain's all real numbers. Now, second, we look at the output that we just got, which is a radical, so we need to set the radicand greater or equal to 0, and that's going to tell us our domain. We're going to get 2x is greater or equal to 2, which means x is greater or equal to 1. And so, basically, we take what we had, which was all real numbers, but we have to restrict ourselves if there's any additional restrictions as a result of what we got for an answer. Well, that's x is greater or equal to 1. That is going to be our domain here. All right, for g of f of x, we'll start like that. Let's plug in f of x, which is the square root of x plus 1. And now we're going to plug that into the g function. So it's 2 times my input minus 3. And square root of x plus 1 is our input here. So we end up with 2 times the square root of x plus 1 minus 3. So again, to find the domain, we look first at the inner function f of x. And notice you've got square root of x plus 1, so we're going to want to set x plus 1 greater or equal to 0. We get x is greater or equal to negative 1. So the domain of f is negative 1 to infinity. So now if you look at our final answer, we also have a radical there, but x plus 1 is also underneath there. So if you set that to be greater or equal to 1 or 0, you get the same thing we just got. And so that is going to be our domain. It's basically what these two domains have in common. All right, and then let's do C here. This is h of f of x. But f of x is the square root of x plus 1. So we're going to plug that into the h function, so it just becomes 1 over that. I don't really need the two different colors there. So this is our final answer. So let's look at the inner function, f of x. So we're going to have x plus 1 greater or equal to 0. We know that's negative 1 to infinity. We already found that one. That was the same as what our inner function was on part B. So if you look at your final answer here, it might seem that it's going to be the same, but notice our denominator there is a fraction. I should say we have a fraction here. So the denominator can't be 0. We want to know when the square root of x plus 1 is equal to 0. Well, that's when x is negative 1. X can't be negative 1. And so our domain, we need to include that restriction. And so we're going to get negative 1 to infinity. All right, let's move on to number 20. So we need to determine which of these functions are one-to-one. So first of all, they are functions. They all do pass the vertical line test. If I want to know if they're invertible, what that means is they're invertible, actually, they're one-to-one if they pass the horizontal line test. So notice here A and C do not pass the horizontal line test, and so they're not one-to-one, and B and C are going to be okay, and so those are one-to-one. All right, let's move on to number 21. It says verify that F and G are inverses of each other. So notice I'm not being asked to find the inverse, I'm being asked to verify that these are inverses. And so here's where we have to remember the definition. We know they're inverses if f of g of x is x and g of f of x is x. In that case, the inputs and outputs would be the same, which means when you run the two functions back to back, they undo one another. That's what an inverse is all about. So let's find f of g of x. That's going to be f of 1/2 x minus 3. So we'll plug that into the f function. It'll be 2 times my input plus 6, or 2 times 1/2 x minus 3. So when we distribute here, 2 times 1/2 x is just 1x or x. And 2 times a minus 3 is a minus 6. And let's bring down the 6. We're going to end up getting x here. Let's find, so far we're good. We got x. G of f of x, that's g of f of x. In this case, we're plugging in our input of 2x plus 6, that's f. And we're going to plug that into the g function, so it's half our input minus 3. So g of x is our, f of x, 2x plus 6 is our input. And we want to distribute here, we're going to get x plus 3, half of 6 is 3. Don't forget to bring down the minus 3. And so we do get x. So in fact, these are inverses. If we would have gotten anything other than x, we would have said no. All right, let's move on to 22. So we're supposed to find the inverse functions here. So we have 4 steps. The first one is to replace f of x with y. And then we're going to switch x and y. That's one of our key steps. And then we solve for y. That's the other key step. And then the final step is just changing back to the inverse notation. Replace y with f inverse of x. So on letter A, we're going to change f of x to y. We're going to interchange x and y. And now we need to solve for y. So we're going to have to divide by 7. We're going to have to add 2 to get that y all by itself. We know we always add or subtract first. So we'll get x plus 2 equals 7y. And then we can divide by 7. And so we're going to get y equals x plus 2 over 7. Don't forget that last step. We need to write it in inverse notation. So f inverse of x equals x plus 2 over 7. So again, I would encourage you to maybe try B and then watch the video if you haven't already tried it. Alright, so here we have y equals x cubed plus 4. Let's interchange x and y. And now we need to solve for y. So we're going to have to subtract 4 on both sides. And notice we're one step away from getting y by itself. What's the opposite of cubing? It would be taking the cube root. So I'm going to rewrite this and take the cube root of both sides. The cube root of y cubed is just y. On the other side, we have the cube root of x minus 4, and so all we need to do is switch to the inverse notation. Usually we use f, g, and h, but we can use other letters. But we tend to use f, g, and h. Alright, so letter C is where things get a little bit harder, although we're doing the same steps. We'll replace h of x with y. Let's interchange our x and y values. And notice y is in the numerator and the denominator here, so this is going to take some work. First of all, I'd want to get rid of the fractions. I think that's about all we can do here. Let's multiply the right side by y plus 3. Notice those y plus 3's will cancel and you get 2y. Of course, whatever you do to one side, you have to do to the other. And we need to distribute here. If you want, you can put the x in front. But you're going to get x times y, or xy, plus 3 times x, or plus 3x. Now, if I'm going to solve for y, I need my y terms on the same side. So let's get rid of, well, let's subtract xy, and we can get both y terms on the right. And now we can actually factor out a common factor of y on the right. We're doing the distributor property backwards. Notice y times 2 is the 2y, and y times a minus x gives you the minus xy. So we just factored out a y. And so now we can divide each side by 2 minus x. And so final answer is h inverse of x equals 3x over 2 minus x. Or you could factor out a negative and pull that out front and be negative 3x over x minus 2. All right, on number 24, it says find or graph the inverse. So the first thing I would do is identify some points on the graph of f. Let's call it f. So we could write those points out. And you got negative 4, negative 5, negative 3, negative 2, negative 1, 0, and 3, 1. So we know that if we switch the x and y values, we'll have points. I'm sorry, I missed one there. We'll have points on the graph of the inverse. So just switch your x's and your y's. Don't change any signs. Just switch x and y. And now let's graph those points. So it looks like that. Now, you got to be careful. Sometimes students will draw this incorrectly. It's not a bad idea to put in the line y equals x, because we know we're going to have symmetry through that line. That's always true with a function and its inverse. And so I would just kind of work from left to right and just try to make sure that I have the symmetry through that line. And you can see they are symmetric. So the blue graph there is our final answer. So on number 24, the last problem here, you got to find the x and y intercept. So what we normally do is make a little table, and to find an x-intercept we let y be 0, to find a y-intercept we let x be 0. So I'll choose x to be 0 first. Notice 5 times 0 is 0, you're going to be left with 2y equals negative 10, and so y is negative 5. If you let y be 0, you're going to end up with 5x equals negative 10, which means x is negative 2. And then all you have to do is graph those points, and you connect them and you got your line. All right, and this does it for the review for exam 2.